Okay, today I'm going to discuss how to perform normal calculations using the 2.2 activity that we did about Marty and Back to the Future. So in the beginning, we are given that a DeLorean has a mean of 80 miles per hour and a standard deviation of 7.7. So if I was to fill in my normal distribution chart, my mean of 80 goes right at the bottom, and then I add 7.7 multiple times to calculate for 2 standard deviations, 3 standard deviations, and 4 standard deviations. So I have 95.4, 103.1, and then I go backwards, subtracting to fill in the lower standard deviations. It says, what percentage of runs will give the DeLorean a speed greater than 87.7? So when I'm answering this question, I see that 87.7 happens to be on the normal chart, so I don't actually need to perform any normal calculations if I know that I have my standard normal distribution. In my normal distribution, 68% fall around 1 standard deviation. 95% fall within 2 standard deviations, and 99.7% fall within 3 standard deviations. Starting from the bottom, if I know that we have 50% on the bottom half and 50% on the upper half, I can add 50 plus 34, splitting 68 in half to know that there's 34 on the right and 34 on the left. That makes 84% would be, 84% would be less than. So to be greater than, we would subtract and we would get 16% because they're asking for this portion right here. The next question says, what percentage of runs will it give the DeLorean from 64.6 to 87.7? So we have 68% plus this difference, which is 13.5 here. So if we did 68 plus 13.5, I would have 81.5%. Again, I'm just using the fact that 68% is centered. Remember the chart that I drew on our board where I had the different percentages calculated. If I wanted the percentage would give the DeLorean from 64.6, that's starting here and down, we would have 2.5%. Since 95% are around 2 standard deviations and we're talking below that, I have 5% on the outside, but 2.5 below and 2.5 above. Now I get into something where it's asking me about a speed less than 68.45. So I'm going to erase my normal distribution, the empirical rule or the 68.5 information, and just leave what I had at the bottom. And I'm going to ask myself, what is the percentage that would be less than 68? My value would be less than 68.45. From 68, that's right at about here. And I stop. The high value I'm going to go to is from 68.45, but my low value would be from negative infinity. So I could do a normal CDF, my lower bound of negative infinity, my upper bound is 68.45, my mean I know is 80, and my standard deviation is 7.7. So on my calculator, I press second, vars. I want to do a normal CDF. My lower is negative infinity. My upper is 68.45. My mean was 80, and my standard deviation was 7.7. Oop, I have one extra in there. And this gives me a percentage of 0.067. So about 6.7%. Next, it asks what the percentage of runs is greater than 85. So I'm going to go back up to my chart. Greater than 85 is right in this area, and I'm going larger. So I start at 85. So I'm going to go from 85 up to a very large number. So let's say I had 85 up to infinity. Same mean, same standard deviation. Second, bars, normal CDF, going from 85 up to a very large number. And I get 0.258, which is equal to 25.8%. Next, I'm asked about between 70 to 95. I'm going to go back up to my chart again. Between 70 and 95, I'm starting at 70 and I'm going to 95. So I will run a normal calculation, normal CDF, 70 to 95 with the same mean and same standard deviation. So second, vars, normal CDF, from 70 to 95, same mean and standard deviation, and I get 0.877, which is about 87.7%. Now, lastly, Marty wants his last run to be in the top 15%. So what speed does he need to be in the top 15%? So in this case, we're given a percent. And so I don't necessarily have any of these numbers. All I know is that if I have a line, I need this area here to be 0.15, which means that this area is 0.85. And in our charts and with our calculator, when we go inverse norm to find a z-score, we have to use the percentage from the left side. So what I'm going to do is I'm going to do an inverse norm of the area, 0.85, with a mean of 80 and a standard deviation of 7.7. So go back into my vars, inverse norm, 0.85, with a mean of 80 and a standard deviation of 7.7. And my value would need to be at 87.98 miles per hour. Each of these problems can be done using a z-score as long as you took, for example, let's say this value here, if I was talking about 70. 70 minus the mean over the standard deviation would give me the z. So that is negative 10 divided by 7.7, which is negative 1.2987. If I did the z for 95, that would be 15 divided by 7.7, and that's 1.948. So what I would be doing is a normal CDF from negative 1.2987 up to 1.948. But now that we've standardized it, our mean is now 0 and our standard deviation is now 1. So if I go to second bar, still a normal CDF, but now I'm using my z-score for my lower and my upper. And I get 0.877, which is 87.7%. So I can standardize it, or I can just use my mean and standard deviation. All of these can also be done on your chart.